All right, here's our next graph. I'm going to do x of t for you with this one, and I'll get you started on y of t, but that's where I'm going to leave it. So let's start by picking a starting place. I always like to start here if that's an option. It's not always an option, but what I will point out is that it's at an extreme value for x. Another common place to start is at an extreme value for y, so this point up here. Other options include the negative extreme values or, these points out here. But this one here has always been my favorite. I think it makes me comfortable because this is where we tend to start drawing angles in general. We start on the x-axis and we move in the counterclockwise direction. That's how we do trigonometry, right? So I think that's probably why I favor this point, but it's not the only one you can use. And in fact, some of the answers that you'll get will in the interface will have come about because the computer started in this location. Anyway, so I'm going to run through the process again for x for you. And so I'm going to be pointing to the graph here and writing on the graph over here. So the point that I've chosen to start with is 10, 0. That means that my x coordinate is 10 and my y coordinate is 0. So I'm going to plot the point 10. Actually, I'm going to set the scale 10, first of all. And that's the x coordinate. I could at the same time plot the y-coordinate on this other graph. It's 0. I can also set the scale for my other graph because I can see that x is going from negative 10 to 10 and y is also going from negative 10 to 10. So I'm going to have a negative 10 to 10 in both directions. So I've set the scale for both graphs now, and I've made the observation that my first point for x is 10, but my first point for y is 0. And I could, in fact, go back and forth and plot them at the same time. I tend not to do that because I get confused easily. I forget where I was or I forget which coordinate I'm working on. So I usually just do one graph at a time. In terms of x, here I'm at a maximum value, an extreme value of 10. And then if I go counterclockwise, coming into the first quadrant first, so if I'm walking along this line, my left shoulder is into the curve, then my x value is going to come down until it gets to about 3. So at a reasonable distance down the line in terms of t, I'll plot a point that's about 3. Let's put a 5 marker in there just so we have a reference. Then if I keep going, I get down to about 3, and then it starts to come back up again. In terms of x, my graph is coming up again, and it gets about as far as 7. So my next point is going to be about there. I get from 10 down to 3, up to 7, and then it comes down again, all the way down to negative 2. So my next point is going to be about there. Now, I don't know if you've noticed this yet, but I'm just estimating. I didn't say that was 3.25. I don't care that that looks more like 7.4. Doesn't matter if this is negative 1.8. I'm just kind of eyeballing it. I'm just kind of estimating because frankly, my graph is going to be an estimate anyway. My graph is going to be pretty rough, so it doesn't matter how close I get. Once I have the graphs, and the faster I make the graphs, I'll be able to do my in-between points, my averages. I'll be able to do that part quickly, and then I'll be able to find equations. Once I have the equations, I can tweak them once I know what the graph of those equations look like to try to match the graph of the equations that I can't see the answer. So don't go out of your way too much don't overburden yourself with accuracy in this particular piece. So how far did I get? Negative 2, I said. Then my x value comes back up again. Following the loop around, I get up to positive 2. And so again, I'm just estimating. Now I'm up to 2, but now I'm going back down again. I'm going down to, it looks like about negative 7. One thing I will say about estimating is that if this is positive 7, if I'm calling that positive 7, this is going to be negative 7 because the graph is symmetrical. So it needs to be roughly the same number. From negative 7, I come up. Remember, I'm just thinking in this direction, up to negative 3. Negative 3 is about there. Negative 3, I come down from there. I start going down again to negative 10. And that is about there. Now, because this graph is so symmetrical, and they won't all be, I can just reverse the process here. Notice all these points that I was at down here, I was at -3. I'm going to be at -3 up here as well. So I should be able just to kind of repeat the process up here. So let's see, I got down to -10. My next values are going to be -3, -7, +2, -2, -3, -7, +2, -2. See the symmetry there? +2, -2. The next one's going to be whatever this is. The next one's going to be whatever this is. Nope, other way around. My next point is going to be whatever I got to here. The next one's going to be this one, and then this one, and then this one, and then 10. So I have a point here, and then here, and then here, and then 10. So let me verify those for you. They don't look right, do they? They don't look right. So maybe it's better just to go ahead and do it the long way. I got to -10. That's this point right here. I'll put a marker there. And that's the minimum this graph comes to. Then I have -3, -7. So from there I have -3, -7. And then +2, that's where I messed up. -3, -7. This should be a +2. Maybe I just left it out. +2, -2. I'm going the right way. It happens sometimes. +2, -2, 7, 3. +2, -2, 7. So this is in the wrong place. And then 7, 3, and 10. The pointer just stopped working. 7, 3, and 10. All right. So now that I have my graph, I'm going to connect the dots. And that is just a case of slowly but surely connecting all the points that you found in the order that you found them until you get this sort of wiggly little graph. Notice as I do this that I'm making little valleys. I'm not doing straight lines. That is not helpful. It's inaccurate, and it won't help you. Well, you could still do it, I suppose, but it would not necessarily give you an accurate solution. All right, so I'm having trouble with this one here. There we go. I'm coming in a little shy of that point. Instead of going up to it like that, I'm kind of aiming for a little before, like this, and then curving in, because that's what sine and cosine curves do, right? I'm aiming for really about here, and then curving into the point. That one's kind of an extreme example, because that's what sine and cosine curves do. Now, here's where I messed up, and there's a little bit too much space in here, but you get the idea. And if you look at this, kind of squint a little bit, you can see that this looks roughly like a cosine curve. So once again, we have cosine. I'm going to go ahead and find my midpoints, leaving the ends to the end, as it were. It's really easy to find all of these. And then I'm going to look at my ends. Now my ends, this time, if I were to start a new cycle over here, I'd be coming down. And so the next part of this graph looks like that. And the same thing on the other side. So that means that my graph really is at a maximum here and a minimum here. It's at a maximum here and a minimum here. And that means I can put my midpoints here rather than at the extreme end. That would happen if your base graph was a sine graph. So now I'm going to connect these points. I'm going to start in the middle this time, or close to the middle. I am not doing a very good job. This graph is a bit messy, but it's still going to end up more or less looking like a cosine graph. And that's what matters. We're just trying to get at what is the underlying behavior and then what is on top of that. This pink graph is clearly a cosine graph. It's clear to me. I hope it's clear to you. And I only have one cycle between 0 and, when I go around the graph once, I only go around a cosine graph once. So that's just the cosine of t. And the amplitude, I kind of have to guess at the amplitude. It looks to me like it's more than 5, but less than 10. So I'm going to guess that it's about 6. And that's my base graph. Now, that's not the white graph. That's not the answer, but it's where I'm going to start. Then I'm going to look at what I have on top of that. Let me grab a nice thick pen here, and I'll grab, maybe I'll do green this time. What do I have on top of the pink graph here? I have a graph that starts, that's as much as I'm going to do right now. The pink graph is in here, starting about there. And the white graph, which I've now kind of covered up in green, starts above that. So if I want this white graph, I'm going to have to take the pink graph, which is this equation, and add something to it. In fact, I'm going to have to add enough to it to get to 10. So since my pink graph is 6 times the cosine of t, I'm going to have to add 4 times something. So now my job is to figure out what that something is. It's either a sine or a cosine, and I have to figure out how many cycles there are. So when I started this green graph, I was looking for what am I adding to the pink graph? It looks like if I start at beginning, start with t equals 0, immediately over the pink graph, I have to add 4, but that's my starting point for the white graph as well. And from there, if I start above the graph, start above the pink graph, the first sort of full cycle on the white graph looks like a cosine as well. I'm going to move the parts of my equation around because I need a little more room. So I have 6 times the cosine of t plus 4 times, and I've decided, my pen is really misbehaving. 4 times, I've decided that looks like a cosine as well. So I'm going to use a green pen here because that's the color I've chosen for my wiggly graph. So I've decided it has an amplitude of 4 and that it's a cosine graph. Now all I have to do is figure out how many cycles there are between 0 and the end of the graph, which is 2 pi. So how many times do I do this down, up, down, up pattern? I'm up, I go down, up, down, up. How many times does that happen? Well, you can count 1, 2, 3, 4, 5, 6, 7. So that would be 4 times the cosine of 7t. Now, am I guaranteed for the equation for y to be 6 times the sine of t plus 4 times the sine of 7t? No. I mean, in this case, it's very likely because the graph is very symmetrical, but that's not always going to be the case. So I would invite you to continue this process for x. Do this part on your own. This is one of the questions in the tutorial assignment, which is not required, but will help you do the actual assignment. So do the x part of this graph for yourself. See if you can figure out what the equation is based on your graph. And I'll get you started. Let's see, we've already decided that this starting point is at 10, 0. So that means that this y coordinate there is 0. That means the y value at the starting point is 10. I started in this position and I went in this direction to do x. So I have to do the same thing for y. I have to start at this point and go in this direction. So my y value is starting at 0. Notice that for y, it's not an extreme value. That's okay. What I'm going to do, though, is look for the next extreme value, which is about 2. So my first point here will be 2. My next point will be all the way down here at -7. So I'm all the way down here. And from there, my next point, my next extreme value, local extreme value, is about -3. So that should be enough to get you started. Your next one's going to be down here at -10. That should be enough to get you started. Finish that process of plotting points, connect the dots, find the midpoints, the way I did up here, these midpoints. Make sure your ends are correct. I will tell you this, it won't always necessarily be the case, but this is going to turn out to be, I won't tell you that, but it's going to turn out, because it's starting here and going up, when you get to the end, you'll come back to 0. The next part of the graph, if you were to do a second cycle, would go up. Okay, so that means that your graph is going to come down here on that side, even though it goes up on that side. And that means that your midpoints, let me do a little bit more here, connect these first few points. Your midpoints here and here and throughout the graph will be pretty obvious. But the midpoint here is actually the starting point. It's actually 0. Not here, which is where a lot of people assume that it's going to be. So your pink graph is going to come down kind of like that. And then, you'll have to figure out what it's going to do next. So that's all I'm going to do for this video. When you do this in the tutorial, there's a graph and a couple of places for you to write your equations, and you can check and see if it's right. And if it's not, you can adjust it. You might not have the right number of rotations here, or the right number of cycles. You might have an amplitude instead of 6 and 4. Maybe it's really 7 and 3, or maybe it's 5 and 5. Okay, so there are things you can adjust. And once you've got it to a place either where you're happy with the answer and it's correct, or you're convinced that it's covering the graph, and even though the system's not giving you the points, then on the next page, you can see the answer, or you can see an answer. If you want to, then you can go back and put that answer in. But remember, the tutorial isn't for points, so you don't have to do that. The whole point of the tutorial is to give you some guidance on how to do the actual project.